the camera. So basically, I think everyone can see my screen now, right?
Yes,
Yes.
ma'am.
Okay. So children, tomorrow's class I could not able to take. That is why I have conducted it today. Okay. So again, that's why like some 2 to 3 people have not joined. Yes. So Naga, for you only, I'm not in the slide. So see, understanding the flow of the what is the learning objective of this chapter? Okay. Understanding the flow of electric current, we will basically see what is electric current. We'll basically see what is circuit diagram. Okay, these things we will be explain, like we will be seeing, and we will be different understanding the difference between conventional current and electron flow. What is conventional current and what is electron flow? You don't have to confuse your mind so much. What is and what? I will tell one of your friends to explain now what is this electric current, what is this and all. Okay, understanding the different types of circuit based on the flow of electricity. So we will be seeing what are the different types of electric circuits, what are the different type of circuits. For example, for your curiosity, I will say there is two circuits, series and parallel. Okay, there are two kind of circuits. There are series and parallel. Hope my handwriting is not so bad. Okay, then we will be seeing what is cell, what is battery, what is the difference between cell and a battery. And then we will understand the effects of electric current. What are the effects? As Soumya said, it may be heat effect, it will be there. If electric current is there in somewhere around you, what are the effect it can have? An effect of electric current. Okay, I mean factors affecting. What are the factors affecting electric current and what are the effects we get from electric current? So we will see both of that. And then we will be applying this knowledge, of course, applying this knowledge in identifying the components of electric circuits. And then we will understand the discrimination between different type of circuits, why they are different, right? I said two circuits, series and parallel. Not only Sudarshan, everyone, I'm telling, if you are so confused, like what is ma'am telling, don't have to worry about much, okay? I'm just giving you an idea what we will be learning in this whole chapter. So if you are not like, very well versed about what is this, what is that, don't have to stress much. One by one, we will complete, okay? Understanding the discrimination between types of circuits. So there are different type of circuits. So we'll be finding what are the difference between them. And then, of course, last but not least, we will be solving numerical problems, okay? And circuit diagrams for your understanding. Yes. Okay. So, Sudarshan, I highly recommend you to go and watch the YouTube lecture of yesterday's class. Okay. But I will also tell you. So now, okay, let us take. Yes, Ashwant, you were there for the electric current lesson when I was teaching the
Yes,
first
ma'am.
class. Come on, tell him what, like, like short and sweet, like, what is this? What is the slide all about?
Uh, Ma'am told about atoms. Uh,
Mhm.
mm, like atoms have present neutrons, protons, nucleus, and electrons. Uh,
Mhm.
Protons are the positive charges. Electrons are the negative charges. And neutrons are nor positive or negative. They are neutralized.
Mhm.
Uh,
Mhm. Okay.
Ma'am
Yes.
told
Yes.
atom
Correct.
about atom and uh, that's it.
Okay. Anyone else wants to add any other point or
Ma'am,
stuff?
actually, ma'am, you told like atom is not the smallest unit. Like it has more smallest object. Like
Something
ma'am,
called
I
the
forgot
quark.
the name of those.
Something there called quarks, and quick something starts with QU also. So these are the newly discovered particles. Before and all, no, atoms are the smallest one, but after discovery of quarks and quill something, and these two is like not there in your syllabus, but you have to know it, right? This is recently updated. So quarks, after finding of like discovery of quarks, they are telling like quarks are the smallest one. Okay, so yes, Naga, did you get what is an atom?
Yes, an
Okay.
atom is smaller than the human hair. We have learned that all materials are made of small particles called atoms. An
Yes,
atom is smaller than human hair. So,
you're
if
correct.
you are the size of an atom, it will
Mm-hmm.
look like an ant-man.
Not even ant. You cannot see the atom itself. Like
And we can
we
see
cannot.
ant, but we can't see atom.
Yes, actually, we cannot see the atom. Atom is microscopic. It is small particles,
And more than
and
microscopic.
Yes, yes, it is not even microscopic. Yes, that's why like we are like, still in the thing of like how atom looks. As I told you, atom has not like till now they have not discovered what is the how the atom works. So this is a basic structure that theorems and scientists has proposed, but you cannot say these are the finest structure. This is the right structure. You cannot say. Okay. And I was telling about these things about atom, so how atom looks and everything. And then I gave this as your homework. Yes. Anyone did it?
Ma'am, I did the what I say this nylon shirt and plastic chair thing. Yes, ma'am. I think it's static electricity.
Okay. Anyone else? Yes. Anyone else? Adrit, did you do the activity?
No, ma'am.
Hmm. Gilda?
Ma'am, I didn't do the activity since I don't think I was present last class.
Okay. So did you watch the recording?
Forgot to watch recording.
Hmm. Did you remember me?
Yes, I do remember you.
Thank God he remembers me. Yes. Soumya, what about you?
Ma'am, I was absent that class, but I
Very good.
watched the recording.
Yes, you
Uh,
have to see those
I
who are
watched the
absent.
recording, but didn't get time to try it.
That is completely fine. I know I'll give you one free advice. If you guys want to take, you can take. Okay. So never say that you have no time. Okay. Thomas Alva Edison was the great scientist who invented electric bulb. He had also had only 24 hours. Okay. We are just doing 1/4, or can say 1/10 or 1/100th work of Thomas Alva Edison only. Right? Agreeing with me? Yes.
Yes, ma'am.
I'm not scolding you people, okay? Don't take it as a scolding. I'm just telling you, never say you had no time, okay? Because I was like you. I used to exactly be like you whenever I forgot something like I will not do. I'll be telling, ma'am, I forgot. I was not having time. I don't say like that, okay? If you want to do, you can watch the recording in 12 p.m. night also, right? You can do. Am I right? Before going to
Yes,
sleep.
ma'am.
You can watch the recording by 12 p.m. also, or you can watch the recording by 2 p.m. night also. I'm not telling no, don't stress yourself and study. I'm just telling you as an advice, okay? So anyone else did the activity? Is Hamza?
Ma'am.
Yes, did the activity?
No, ma'am.
No. Okay, leave it. Yes, so what does this activity mean? So comb your dry hair. Immediately after combing by the dry hair, bring the comb closer to the bits of paper. What will you observe? So nothing, like bits of paper will be moving and it like partially gets attracted to the comb. That will actually you will see. When you're getting up from the plastic chair, the nylon shirt seems to be stuck to the chair and make cracking sound. What is the reason for the creation of this sound? Okay, fine. A balloon sticks to the wall without any adhesive after rubbing on your hand. Do you know the reason for all the things above mentioned? Can you make a guess what actually happens? Anybody?
Ma'am, it's because of heat.
Because of heat, okay?
Static electricity, I think.
Electricity, okay? They have also already given in all the above activities, when a body rub against some other body, they become charged. Right? So it's a nature in nature. So when a body is there, it rubs another body, they exchange their charges. So as I told you, every body has charges. Even human body is having positive and negative charges, right? That's why we are also getting electric shock. Correct. So when you're getting electric shock, what is actually happening? What is electric shock? What do you mean by getting shock? What is electric shock? Exchange of charges between you and the electric plug, right? For example, you're going to switch on washing machine in your washing machine in your home. You get the electric shock immediately. What's actually happening? The washing machine is passing its electricity to you also, right? You're changing the electric current, both of you, right? So you cannot withstand the electricity that washing machine is giving to you. That's why it's like you get the shock. It's more than your level. 8. Correct? Correct? Getting it?
Yes.
Sudarshan, getting the activity? Have you, Sudarshan, have you
Correct.
ever did this,
Correct.
Sudarshan? Have you ever did these two activities, Sudarshan?
Yes.
Can you tell me what did you observe?
I observed that the comb of remove your dry hair. That after combing the dry hair, bring the comb closer to the bits of paper. What will you observe? When you are getting up from the plastic chair, the nylon shirt seems to be stuck to the chair and make crackling sound.
Yes. What did you observe from
I
that activity?
observe when we put I observe the comb that is used attached by the piece of paper.
Yes.
Bits of paper.
Fine. So
I
actually when
observed that.
you
Thank you.
yeah, good. So you know what actually happened? There is a comb, okay? Remember, this is a comb. Exactly what's happening. There is a comb. Bits of paper will be here. You know, this after rubbing in your hair, dry hair, immediately after combing or dry hair, you know what actually when you are combing, the charges between your hair and the comb actually will also be charged. They will also be charged. And after immediately charging, when you place them on the paper, this charge will be this charge will be imposed onto the papers. That's why the paper will start shaking. They'll get lightly attracted to them, because you know what happens, the charges between your head, your hair, and the comb is already there. They themselves exchange the charges, and the same charges immediately when you place in the paper, this comb will also try to impose the electric charge to these papers also. So that is why, the papers, they'll be having lightly shaking movement. This same applies for this activity and this activity also, right? So basically, this activity is trying to tell you that charges, when two bodies in contact, they exchange charges, right? Right? This is
Yes.
exactly what they are trying to tell. When a body is rubbed against other body, they become charged. Yes, fine. So now we are coming to something called electric charge. Can anyone tell me what is electric charge without seeing the slide? Electric current, something different. Electric charge is something different. Charge is something different. Yes, different in the sense not 100% different. They are interlinked to each other. Can you guess anybody? Yes. Can Naga tell, as you are a new student, what do you know about electric charge?
Electric charge. Electric
Yes.
charge is the physical property of matter that causes to experience force, hence placed in an electromagnetic field. The positive and negative electric charges are the two types of the charges commonly carried by charge carriers, protons and electrons. Energy is created by the movement of charges, right? Cool.
Yes, correct. So electric charge is nothing but a physical property of matter that causes it experience a force. Hence, electric charge. What is electric current? What is electric current? Flow of electric charges. Flow of electric charges.
Really? Flow of electric charges? Electric
Yes.
charge is measured in a unit called a coulomb. One unit of coulomb is charge of approximately 6.242 into 1018 protons or electrons. Electrical charges are generally denoted by the letter Q.
Okay, nice. So actually 10 power 18 will come up. I think mine it will come to be plus 18 up as a power, it will come. Okay, so you know what? I'll be telling you now in a simple words. Remember, there is a electric wire. Remember, this is a wire. Okay. So the wire is conducting electricity. For example, this is the switch box. This is your washing machine. For example, some of electric appliances. You're switching on the switch. And the electricity started flowing into the wire. Instead of putting like that, electricity started flowing into the wire. positive, negative, positive, negative. Remember, like these are the electricity. They started flowing into the washing machine. Remember, sorry, listen everyone carefully. Okay. So, lot of electrons, I mean, lot of charges, they are started flowing into the washing machine, and washing machine gets the electric current, it starts running. So, each of this is called as charge, electric charge. And group of electric charges flow into the conductor to form electricity. Now, got what is electricity and electric charge? Yes? Answer me, anyone? Anybody?
Ma'am, electricity is electric charge is when the person gets a shock when the waves are moving.
Okay. Okay.
Electricity is the thing which powers a thing.
Okay, fine.
Powers the electric thing.
Yes, Sanidhi. Yes, Sanidhi. Yes.
Ma'am,
Yeah, you are. Yeah, Ashwant. Yes.
ma'am, electric charge is a small unit of electricity.
Guys, I'm asking, did you understand whatever I told you now?
Yes, ma'am.
Soumya, did you understand?
Yes, ma'am.
So what I told you, remember this is an electric plug. Once again I'll tell you. So I am telling you a key thing to remember: what is electric charge, what is electricity, difference between them. This is a switch. Okay, this is a switch. This is your washing machine. Okay, when you power on the switch, when you switch on the switch, your washing machine starts running. Okay, so actually what happens? You have wire connection between your switch box and the washing machine, right? They are connected with the help of wire. So actually what happens when you switch on, electric charges starts flowing into the wire. Electric charges started flowing into the copper wire, and they reach the washing machine, and hence washing machine gets the current and they start running. So the flow of electric charges only is electricity. When group of electric charges flow into an insulator, like, sorry, not insulator, into a wire, get a copper wire or whatever wire it is, then they make up electricity. Flow of charges is only electricity. So this is nothing but the flow of charges, right? Am I clear? This is the flow of charges. Can you see this is a flow of charges? Lot of positive and negative charges are from the electric switch box to washing machine. They are running, right, in the wire, right? Right?
Yes,
Is it
ma'am.
right?
Yes, ma'am.
Yes. So this individual positive, negative charges are nothing but charges, electric charges. And when they group up, and flow in a particular direction towards some appliances, they form electric current. Correct? Got
Okay.
it?
Yes, ma'am.
Okay, ma'am.
Everyone got it?
Yes, ma'am.
We will come to the formal
Yeah.
definition of what is electric current and charges.
Ma'am,
Yes.
these electric charges only keep flowing when we, like, suppose the electric appliance is a fan or a light bulb. When we on the switch only, they start moving, right?
Correct, exactly. When you on the switch, there will be electric charges everywhere around you. Even the charges are present in the atmosphere, but in a static position. In a static position. What do you mean by static? No movement. There will be like electric charges around everywhere, but they will be in static position. Means they will not move. For example, one more slide I'll include. Wait a minute. So this is an Wait, a lot of disturbances there in this slide. So there is a room. Remember, there is a room, okay, or atmosphere. Negative and positive charges are there without colliding each other. They don't collide each other. They are just present as an individual stuffs. Until unless you gave some force to them, they won't move. They will be in the same position. Until unless you give a driving force to them, they won't move. So here, if from switch box to, washing machine, you're driving the electric charges. You're giving some force. I mean, the force in the sense, it's not like exactly somebody is pushing. Yeah, that is what like electricity
Ma'am, for this,
generation.
can you use the example of AC?
What example? Same example. Have the switch.
Ma'am, no, AC.
Yeah, you have a switch. You have AC. You have wire connected from switch to AC. Whenever you power on the you power on like the AC.
Actually, for AC, we have a remote.
Ma'am, no, because like AC uses electricity and then that water converts to air.
I need you into.
That cold water.
No. See, the air is getting I mean, water is not converting to air actually in AC. It is getting the air, atmospheric air. It is cooling it and again pushing back into the room. So there is an AC window. Sorry, this is a split AC. Remember, this is split AC. There is a fan outside. This
Yes,
fan
ma'am.
basically takes the this air basically takes the atmospheric air. They condense it. What is condensation? Cooling process. Everyone learnt in 6th standard. Remember?
Yes, ma'am.
Yes.
Condensation is cooling process. Takes the atmospheric air and condenses it. It cools down. It cools down, and basically with the help of the pipe, it sends the cooling condensed air to the AC, and AC is just going to blow up the air. The split AC, that white color thing or the blue color thing or the red color thing you see inside your room, is just going to be a transformer. It's just going to be transforming the air from outside to inside. It does not have any other work other than transforming the air from outside to inside. Okay, the real work is done by the outside motor, the AC fan. Yes, the condensed air is coming to these, and these all process takes place in the presence of electricity only. Without electricity, this cannot happen, because electricity is going to provide the force to this. I mean, force in the sense it's going to provide the energy, electric energy. Electricity is also called as energy. They are going to provide energy to all the appliances. For example, this is washing machine. Okay, I'm switching on. Okay, what I'm actually doing, I'm giving some energy to the washing machine to do the work, right? What energy I'm giving? Electric energy, right?
Ma'am,
Ma'am,
ma'am, there's some appliances which have remotes, not switches. So how do they get on or something?
See, switches, remotes does not have any connection between electricity. One question I will be asking you. So remote control is just used for on and off purpose. It is not used to, there is no connection between electricity and the remote. How I am telling you is, for example, you can take AC itself. There is a main switch for AC, or you can, no, we don't want to take AC. We can take TV. Okay. You have a TV in your home. My question to you is, there is something called main switch in the TV. You switch on the main switch, and then only, right, you will switch on the TV remote.
Ma'am, but
Am I right
how does it
or wrong?
on and off, ma'am? Is there some signal between those two?
Yeah, see, that's what I am telling. We are talking about electric current. We are not talking about IR radiations. We are not talking about UV radiations. Like, you have some radiations between the remote that will be passing to this, and they will have connection here, and the remote and this TV will have a certain connection. That is radiation. They use radiation, UV or something, IR or UV radiation they use. With the help of that, they communicate with each other. They pass signal to the radiation. We are not into the radiation itself. We are in the electric current. Electricity is something different, and radiation is something.
what if the remote doesn't
Ma'am,
work?
are the radiations powered by cells? Because these remotes have cells.
Cell in the sense you're talking about the battery.
Yes, ma'am, battery.
Yeah, of course they will have, right? So that is what I am trying to make. That's the exact point I'm trying to tell you, everyone. So every appliances need energy in some or other way. So you are giving energy to your TV with the help of switch box. You're switching. See, your main switch box will be there. Are you all aware of that? When you on the switch only, then only remote itself work, or else remote won't work. Right? Am I right or not?
Ma'am, if the
Yes.
remote doesn't work, will the TV send radiations but the remote will not?
No, yeah, they won't work. Unless you switch on the main plug of the TV. So, oh my God, now I want to teach how to switch on the TV. So see here, there is a TV. You will be having a plug, right? You will be having a plug. Once you switch on the main plug, switch off the TV, you will see the red color light is coming into your TV. Once the red color light is coming, then only you will switch on the TV with the help of your remote. Am I right or wrong?
Yes, ma'am.
Ma'am, you are right.
Guys, do you all know the process of switching on the TV?
Ma'am,
Yes,
first we on the
ma'am.
main plug, and then the red light comes on the TV, and then we use the
They will
remote or
switch on,
click the
right?
button, or sometimes we click the button below the TV.
Yeah. So sometimes when your remote is not working, actually we do that thing. We will switch on the button and the TV starts. Right. So my question is, there is no connection between. So even you're giving electric current supply to your TV with the help of switch box. Okay. You're still. What happened? What happened? Oh, what is your name? I forgot. Yes. What happened, Shritesh? You are still not getting what I'm saying.
Ma'am, I am getting.
I will tell you one last time, okay? One last time, very clearly, I'll tell you. There is a TV. I hope you all are aware that there will be wires coming out from TV. Are you all aware?
Yes, ma'am.
There is a switch box. TV will be always installed behind the switch box. Are you all aware that? Aware of that?
Yes, ma'am.
Yes. There is something called plug here. That plug will be connected to the switch box. Are you all aware of that? Yes or no?
Yes, ma'am.
Yes,
There will
ma'am.
be a switch. You will switch on. You will switch on. You will switch off. TV will not work. Even though you have remote, you press it 100 times. Also, TV will not switch on until unless you switch on this main switch. You are switching on the main switch. Then electricity flow of charges. You will say flow of charges will now flow of charges will be moving from the electric switch box to here. Right? Electric switch box to here, then TV will on, the red light will come, and then you, that is a signal actually, that is the key signal you have, and once the red light comes, you switch on the TV. And for TV to work, we need electric current. Electric current is given by the switch box. Basically, the switch box in the sense transformer gives you electric current to every home, and from the transformer, switch box will get the electric current and it will pass through the appliances in your house. Am I clear?
Yes.
Clear. Everyone should answer.
Yes, ma'am.
Soumya, are you there in the class?
Yes, ma'am.
Yeah. Okay. So once you switch on, the electric flow of charges will pass through the wire to the TV. TV will not work still because you have to switch on the TV with the help of your remote. And in remote also you have batteries. What is battery? Battery is also giving you electric charges. They are also giving you, the electricity for the remote to work. They are also a kind of energy. They are giving energy to the battery. Sorry, they are giving energy to your remote so that the remote will also work, and the energy, that electric energy you're getting already for the TV from the switch box. And why this mechanism is there means, every time you don't want to, like, for human beings is only, this mechanism is there. Whenever you want, you can just use your remote. Wherever you are, you can use your remote and click on the front of the TV will on. Or else every time, if the remote mechanism itself not there, every time you have to go to the switch box and switch on the TV, and whenever you want to off, you have to again go to the switch box and switch off the TV, right? So when you are having remote, you don't have to every time go near the switch box and switch off the TV, manually. You can use the remote and tuck, tuck, you can just, with the help of power button, you can switch on, switch off, you can control the volumes. So various control things are also there in TV. That is why, to ace the humans, human interaction between the TV and the human, between the interaction of two, to ace that process only, we have remote. Remote has nothing to do with the electric current chapter. Remote is different chapter. Okay. Okay.
Ma'am, I think they will ask about to make a chapter about TV and electricity or
No,
remote.
the signal between the remote and the TV is something different. That has nothing to do with electric current.
Okay, ma'am.
Okay. Okay. Now this is definition of electricity. Okay. Flow of charges in a conductor is defined as electricity. As I told you, there is a conductor, switch box, and some appliances. Flow of electric charges. So plus positive and negative charges are flowing. Right? So the flow of electric charges is nothing but electricity. And these individuals are nothing but electric charges. Individual charges that you are seeing in the wire flowing from switch box to your appliances. The total flow. When they flow, they make up electricity. When they don't flow, when they are in static position, they are nothing but charges. Understood?
Yes, ma'am.
Understood? Okay.
Yes, ma'am.
Now tell me, I will be asking questions now. So there is a switch box. There are some 4 appliances. Take AC, washing machine, TV, fridge. All are connected to electric current with the help of, this is the switch box that you have in your home. When you switch on, these
And there should be like
people
a
will
four
work.
plugger, and then that four plugger should be connected to this.
No. Don't want to confuse that. They all have separate plugs. Don't worry. Okay. Plug has nothing to do with. They all have separate plugs. Now, can anyone explain me the electric charge and electricity? Electric charge and electricity. Can anyone explain me?
Ma'am, electric charge is like the flow of positive and negative charges.
What is what?
Ma'am, electric charge is like the flow of the charges.
Electricity is flow of electric charges. What is electric charge? Positive and negative charge. I think not understood. Fine, very good. Now, I think now I'll be re-asking the same question. There is a switch. There is an insulating wire. There is a appliance. You can take any appliance, for example, fridge. So now, once you switch on the electric board, I mean, once you switch on the switch, the charger starts flowing. Now tell me which is electricity and which is the electric charge here.
Ma'am,
Ma'am,
positive and
ma'am, the
negative
positive and negative is the electricity, and then sorry, ma'am, when you on the
Positive and negative are the charges.
Very good. These two are charges. When they start flowing, when they start flowing, when I switch on, they start flowing. The flow of charges is electricity. Flow of charges. When the charges shows movement, please remember very carefully. When the charges show movement, when the charges move from one position to another position,
Instead of flow, you wrote
become
how?
electricity. What?
Instead of flow, you wrote how?
No, it is flow. F. It is F. FL. Okay. When they are in static. So now, Sritej, now tell me, there is a room. I told you, right? The room also have charges, but you can't see them. Room also have charges, right? There will be a static charge. Static charge means no movement is shown, right?
Yes, ma'am.
Now tell me what is electricity, what is charge in this?
Ma'am, the positive and negative is the charge, and when they flow, it is electricity.
Exactly. Everyone understood? Is there any flow here, Sritej, in the room?
Well done, Sritej, my friend.
Yes. Is there any flow, Sritej?
No, ma'am, they stopped.
When will the class end?
Very good. So there is no electricity, right? Everyone got? Is everyone got?
Yes, ma'am.
Very nice. I
Yes,
thought of giving you some problems today, but we don't have time. I thought of giving you the problems, which I'll be showing the problem. I thought of giving you I thought of explaining you this, like what is, my screen share is loading. Okay. So I thought of explaining you this electric component symbol, what is battery. I thought of completing like what is battery and difference between battery and cell. Okay, no,
I'm back to
no
Paheli and Bojo.
problem. See, actually this picture. Paheli and Bojo, yes, they will be traveling with you throughout this 1 year. For a full 1 year, they'll be traveling with you. Yes. So this is a cross-sectional area. What is cross-sectional area? This is a piece of wire. This is a piece of wire that I was trying to tell you. No, there's a picture here. The piece of wire. This from here to here. It's just a piece of wire zoomed out, like zoomed in to show you properly. So these are the charges. Can you see electric yellow color things are the electric charges. So why they have put the arrow like this means they are in the flowing, they are now actually flowing from one place to another place in, through the wires. So actually the flow of electric charges is electric current.
In sixth grade, they taught us
And the
something,
charges
right? In conventional current, it is
nothing but
positive and
electric
negative.
charge. So they have given
Is there a thing called like normal current and
conventional current and electric flow.
Yes, ma'am.
Yes, we have. Yes, we
Conventional
have.
current, it
So
goes positive to negative.
yeah, it's just an opposite. One more electron flow or electric flow. That is just opposite to that. That we will be coming to it. Before that, we have to see what is battery. Before that, we have to see what is cell. What is the difference between battery and the cell? Everything is we have to see. Then only we can go to types of current, like conventional or something like that. We have so many things to discuss. We'll be discussing. Yes. Now clear? Clear?
Ma'am, your voice is low.
Is any doubts are there in today's class, Gelda?
Now I understood.
Yes, Soumya?
No, ma'am.
Okay. So there should be no confusion whenever I ask what is electric charge and electricity, right?
Okay, ma'am.
Yes, ma'am.
When electric charges flow in a wire, they become electric current actually. When they are not flowing, when they are static, when there is no movement, when they are in the same place sitting, then they are simply called as charges, right? When they start flowing, then they make up current. They actually called as current. Yes.
Okay, ma'am.
Fine. Okay, then bye. We will see the next
Bye,
class.
ma'am. Thank you, ma'am.
Bye bye.
Okay, ma'am. Bye, ma'am. Thank you, ma'am.
Bye, ma'am. Thank you.
Do you have any doubt, Sudarshan?
Bye, ma'am.
Do you have any doubt?
No, doubt clear.
Is everything clear today?
Yes. Bye.
Okay, you please go and watch the recording of nutrition in plants. Okay.
Okay, bye.
Bye bye. See you.